Okay, so welcome back. We finished off part one just to sort of naturally break it up. So we left it at looking at gathering together all the less than or equal to signs and separating them out from all the greater than or equal to signs. Now, in terms of maximum of all silk, take a look here. We've got all of our monthly demand, which will represent the maximum, and this will represent the minimum. All right, so if you look at something like silk, what they're saying is we would like to have 7,000 or less or fewer ties. And then anything within that range, they're happy. 6,500, they're happy, but they wouldn't be happy with 5,000. They wouldn't be happy with 8,000. So we need to put in all those range. And we've broken it up in terms of putting it together. And this will be the maximum all silk. So in terms of maximum all silk, we put a 1 here, right? And this is going to be, when we do our equation, based on what we have here, right, it's going to have this number, and then it's going to be multiplied by whatever a number of ties, and then it's going to be compared to this maximum. So the maximum is 7,000 ties. So we put 7,000 ties for silk, and then next for polyester. All right, for polyester. And polyester ties, the maximum right here is 14,000. So we could put in 14,000 for that part. And then we have blend 1. So blend 1 ties, they said the maximum for blend 1 ties, they want a 16,000. All right, and for blend 2, all right, for blend 2, then we've got the maximum of 8,500. We can pop that in. All right, 8,500. Okay, scroll down. We're going to have the minimum for all silk. All right, and again, we would click here, right? And then due to what we have for the sum products, right? So if we click on the sum product, it would be this amount of 1 multiplied by however many they made. And since everything else across here is going to be 0, it's going to be just adding up zeros, which means it doesn't matter. And this is going to tell us how many silk ties were produced, and it's going to compare it to the minimum. All right, and the minimum was 6,000, as you can see. So this would be 6,000. And then for polyester, in terms of the minimum, take a look here. Minimum was 10,000. Okay, next we're going to take a look at the minimum for blend 1. You can see the minimum is right here for blend 1, 13,000, and the minimum for blend 2 is 6,000. So we can pop that in. So 13,000 and 6,000. All right, it's very important that we have the ones in here. All right, and we can test. Again, if you test, you'll see that it's getting this number here, but this number is blend 1. You can see that there's the 1 there. This would all be zeros, and this 1 will correspond to the blend 1, the number of blend 1. So it will be the number of blend 1 multiplied by 1, will just give you the amount of blend 1 here, and then it would be compared to this number here. Okay, so these are all dollar signs, so I need to format that because these won't be actual dollar signs. These would be, let me just go into format here, format cells, and then number. So it's not currency. We want to have it just as a number because these are going to be amounts of things such as number of ties. All right, so we don't need that as a dollar sign. So everything else is in place now. So what I can do is grab solver. Okay, so go into data and go into solver over here. Let me move that over so you can see. Okay, so for solver, what we're trying to maximize is profit. So we would go onto here for maximizing profit by changing the variable cell. So this would be changing the number of ties produced. All right, and then for constraints, we can add in our constraints. Okay, look down here. We can group all these. If you can see all the less than or equal to's, we can group those all together. So that would be, this would be the left-hand side, stopping here, and then less than or equal to, so that's matching up. And then the right-hand side, we need to match that up as well. Okay, so we got 8,000. Perfect. Okay, so we add that in. And then the next grouping is all of the greater than or equal to. So left-hand side right here, greater than or equal to. And then we got to change this over here. So this is greater than or equal to. And then the constraint. All right, we're good. And then just put OK for that. So we got our two constraints. So now we can solve this, hope for the best. And then press OK and see what we got. All right, so we can compare. So we got $120,196. If we compare it to the answer key, it looks like we got the same one. So that's looking good. And take a look up here. So this is all whole numbers when it comes to the number of ties for each. And you can compare in terms of, let's say yarns of silk is less than the max. And it looks like they used up all of the yarn for polyester and for cotton. All right, in terms of maximizing all silk. So the department store wanted a maximum of 7,000 and they sold 7,000. But notice here, 14,000 for maximizing poly. And it looks like they did not, there's some more money to be made, right? They sold them 13,625 units. But the department store says, yeah, we'll accept up to 14,000. Same thing for here, for blend one. The maximum was 16,000. They said, sure, we can take up to that much. But notice that they were short of that. It's within the range of keeping them happy, but it does fall short. Blend 2 did meet in terms of their requirements. So they were met there. So there was some money left on the table in the sense that they could have sold them more. And what we'll look at in the next problem was, well, what if instead of making absolutely all of our ties, what if we could outsource some of our ties such that we can sell the maximum amount? So see, looking over here, we got some shortfalls. What if we could close that gap by saying any difference that we have left over, we just outsource that, and then we make sure that we can meet all of the maximums. And that's what I'll look at in the next video when we look at the make-buy decision.